This video is on solving two-step equations, and I hope it helps any of you who are having a bit of trouble with how to solve the equations we've been doing in class. So let's have a look at what's required in Year 7. The most number of steps for an equation that you need to be able to solve is a two-step equation. So these are the kinds of examples, all of these equations you can see on this slide. Those are the kinds of equations you need to be able to solve in Year 7. And we've talked about in class this week that all an equation is a mathematical statement about two expressions that happen to be equal. So I can see here that 4h minus 3 is equal to 12. And my goal is to find out, well, what is h? And the way we find out what h is we do inverse operations or reverse operations. So what am I reversing? Well, each equation will be made up of different operations. So here I can see that there's a 4 and it's being multiplied by h. So that's one of the operations. And here's my other operation. We've then subtracted 3. So by reversing these operations, we can then isolate the variable or find out what the value of h is. So my next question then is what do I move first? I can see in this equation I've got a 4, a times 4 and a minus 3. I've got a minus 1 and a divide by 4. I've got now here, I don't have anything in front of the 7. So what's being done here? Well, it's a positive 7. So that means we added 7. So I have to reverse it. So I've got a add 7 and a times by minus 5. What do I reverse there? Here I have a divide by 4 and a minus 1. So, and here we'll talk about what to do with these equations here on this side. But what do I do first? So let me just erase all my scribbles. Let's talk about what operation to reverse first. In simple terms, I always like to move, or you need to move, whatever's attached to the letter, it has to go last. So if there's any number and it's joined directly to the letter through multiplication, that has to go last. And that makes it a bit easier because you can see then, so here the 4 is joined to the G directly, so the 4 is going to go last. That makes it easier to see that with all these examples, because it's only two-step, you'll move the other operations. So here I'll reverse the minus 3 first. Here, when there is a divide by 4, well, that divide by 4 blocks the g minus 1, so I'll have to remove the 4. So whenever you have a denominator, that will have to go first, unless it's like this example where the divide by 4 only blocks the g, so I can move the minus 1 over here in this example first, and then I'll deal with the divide by 4. Whereas in this example, the g minus 1 is being blocked fully by the 4, so the 4 has to go first. So here I'll do the 4, here I'll do the minus 1. Over here we know the times by minus 5 happens last, so I'll have to reverse the plus 7. With these examples at the bottom, we've got like terms on the left-hand side of both of these equations. So we talked about in class that really the first thing you need to do is collect like terms. Okay? Whenever you have like terms on the same side of an equation, you must collect like terms first. Collect like terms first. I hope you can understand my writing. All right, so let's get stuck into it. Let's solve these equations. So we've already talked about the fact that we will move the times by 4 last, so that's going last, so this will be what I reverse first. So the reverse operation for minusing 3 is to add 3. So I'm going to add 3 to both sides. I always line up my equal signs. There should only be one equal sign per line joining the left-hand side and the right-hand side. Please do not start each line with an equal sign. For an equation, there is only one equal sign per line. So when I add the minus 3 and the 3, well, they will cancel. We'll get 0. So really all I'm left with on the left-hand side is 4h, and on the right-hand side I'm left with 15. Then I've got this operation of timesing by 4 to reverse, so I will reverse it by dividing by 4. And then any number divided by itself always gives you 1, so we're left with 1h or just h. And the answer is 15 on 4. If you want, you could write 3 3/4 or 3.75. Any of those answers is fine, but just know that your answer will not always be a nice whole number, an integer. So expect decimal answers, expect negative answers. Over here, I'm going to move the plus 7 first. I know it's a plus because it has no sign, and if it has no sign, there's an imaginary plus sign in front. So to reverse adding 7, I will subtract 7. And then I'm left with minus 5m. So we have minus 5m on this side, and over here 42 minus 7 is 35. The next operation I'll reverse is timesing by minus 5. The opposite of multiplying by minus 5 is to divide by minus 5. Once again, any number divided by itself is 1, so I'm left with m or 1m, and 35 divided by minus 5 is minus 7. All right, next set of equations. We talked about how the 4 blocks the g minus 1, so that will be my first operation, is to reverse the divide by 4. So the opposite of dividing by 4 is to times by 4. Pay attention to how I write times by 4. I want it in the numerator so that we can see that this 4 in the denominator will cancel with this 4 in the numerator, because they both can be divided by 4, leaving imaginary ones. So we're left with g minus 1 on this side equals 44, because 11 times 4 is 44. And I'm going to reverse the minus 1 by adding 1, so left with g equals 45. Next, I've got this question where I can see that the 4 only blocks the g, so the minus 1 is free to move. So I'm going to add the 1, add 1, and I'm left with then just a g on 4, because the minus 1 and the plus 1 will cancel. On this side, the right-hand side, 11 plus 1 is 12. And now I'm going to reverse the divide by 4 by timesing by 4. Notice how I've written it, so that these 4s will cancel, and we're left with g equals 12 fours, which is 48. Right, down to our last two equations. These are the equations where you must collect like terms. Like terms on the same side must be collected. You cannot collect like terms if they're on opposite sides of the equation. So we've got here 1a minus 11a is minus 10a. So we get minus 10a equals 90. And then I just want to reverse this operation of timesing by minus 10. And I'll reverse that by dividing by minus 10. So any number divided by itself gives you 1, so we're left with a, and 90 divided by minus 10 is minus 9. Finally, this equation, 6e minus 3e, well, that will give me 3e equals minus 27, and then I want to reverse this times by 3, so I will divide by 3, so we get e equals minus 9. All right, I hope this video helps. Enjoy.